Welcome back to the penultimate lecture in our Foundations of College Algebra series. Today we're going to begin the final module, which is graphs. Again, this is something you will spend a lot of time talking about in college algebra. So first, if you remember, we talked about way back in, I don't know, it was module 3 or 4, the real numbers. And these real numbers are the ones we would usually think about, and they lie on a number line, and zeros on that line. If you remember what the real numbers were, we have, let's put some examples up here. 0 is a real number, 3 is a real number, -5 is a real number, 2/3 is a real number. So we have the counting numbers, we have negative counting numbers, we have fractions. We can also have things that can't be represented as fractions, such as pi. These are all real numbers. And they all lie on this number line. Any number that you think of as a typical number is probably a real number. So we can think about two of these lines. Here's one of them. And we can think about another one intersecting it. And let's say they intersect where they're both equal to 0. So that point there is 0 on both axes, or both lines. They make a right angle with each other. If you're familiar with geometry, that means they make a right angle. We're going to use this method, this thing that we've constructed here, a whole lot. As a matter of fact, you'll be using this for the rest of your mathematical career. So this is a very important topic. We call, with this setup for what we'll be doing with graphs and plotting, we call the horizontal axis the horizontal line the x-axis, and we call the vertical line the y-axis. And notice that this takes the plane, two-dimensional space, and partitions it into 4 different quadrants. We have quadrant 1, and for some reason we go counterclockwise through this. I'm honestly not sure the reason, but it is the standard convention. So quadrant 2 is counterclockwise to quadrant 1, and counterclockwise to that is quadrant 3, and counterclockwise to that quadrant 4. Now notice, these quadrants, because they're intersecting, these two lines, these axes are intersecting at 0, 0, where they're both 0, then quadrant 1 is all positive x values and positive y values. Quadrant 2, since it's less than 0 on the x-axis, it's negative x values, but it's still above 0 on the y-axis, so it's positive. And that is negative on the x-axis and negative on the y-axis for quadrant 3. And then quadrant 4 is going to be positive on the x-axis and negative on the y-axis. Now, we can think of this plane, what we've constructed here is a plane. These go on forever in all of 2 dimensions. And we can think of imposing points on these planes, on this plane. So for example, we can put a point here, or we could put a point here. Right, they're infinitely small. They're just little points. They don't have any breadth. They don't have width or height or anything like that. Thickness, nothing. They're just points, and they represent a particular location in 2-dimensional space. And you can think about these points as some combination, and maybe I should use a different color. You can think about these points as some combination of x value and y values. So I can describe this point here as some x value and some y value. And the way we write that is going to be a little confusing because it's going to kind of overlap with interval notation. But the way we write that is x, comma, y. So for example, let's say that that point is at 2 on the x-axis and 3 on the y-axis. We would write that point as 2, 3. And every point in this space has a unique ordered pair, and every ordered pair has a unique point in this space. So let's do some plotting. We're going to want to plot the point 1, 3. Okay, the first point is always the, and maybe I'll make a really big graph, is always the x-coordinate. The second point is always the y-coordinate. So we go left, right first, and then we go up or down. So going left, right first, let's see, there's 1, there's 2, zeros here in the middle, and we get -1, -2 goes on forever. Here we have 1, 2, 3. We have -1, -2, -3. Okay, so if we want to plot 1, 3, we find 1 on the x-axis. Here we are. This is, you wouldn't plot this line. I'm just doing this for a reference line. And then we find 3 on the y-axis. Again, you wouldn't normally plot this, but I'm doing it for reference. And where they cross is the point 1, 3. This is 1, 3. So there you go. We plotted our first point. I wonder if this thing has any. It has square paper. Let's try that. So we have the. Let's do plot. -7, 10. Let's see, and I may not get this exactly centered here, but like that. So first let's find -7. So we're going to go -1, -2, -3, -4, -5, -6, -7. So there's our -7 point, or our -7 on the x-axis. And then we have 10. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10. We find where they intersect, those lines, which is right here. There's our point, -7, 10. Okay. Let's do another one. I'm just going to draw an axis, or 2 axes, and pick a random point on these axes. We're going to figure out where that's at. This one. Okay. First thing I'm going to do is figure out where the x-coordinate is, or that's what we call it, is the x-coordinate, where it's at on the x-axis, and where it's at on the y-axis. Then I'm going to count. Remember, on the left side, this is negative x values. So we have -1, -2, -3, -4, -5, -6, -7, which is, I think, where we were at on the last problem. Yep, -7. And then on the y-axis, again, the top is the positive, the bottom is the negative. So -1, -2, -3, -4, -5. So that point can be described by the pair -7. Remember, x goes first, -5. Okay. So now that we know how to plot points, there's another thing we need to know how to plot in 2 dimensions. So points, where's my dotted paper? Points have, you don't have to know this, but I'm just going to give you the motivation here. Points have, they are 0-dimensional. Lines are 1-dimensional. And planes are 2-dimensional. So, for example, I called it the xy plane. That's because the xy plane, that plane is two-dimensional. It's a plane. You have an x and you have the y. Lines are one-dimensional. Like, so, you know, this has two different directions. We can describe it by an x and a y. Since we can describe it by 2 points, it's two-dimensional, the plane. The lines can be described, say this one. Lines, all they need is that they're one-dimensional. They have one direction you can go. You can go left or right, but really it's the same direction. You have kind of one axis. Really, this is measuring how many axes you need. For planes, you need 2 axes. For lines, you need 1 axis. For a point, you don't need an axis. A point can exist anywhere in space. So, anyway, all that to say, we're going to look at lines. We've covered points. We kind of covered planes. We're not going to do anything fancy with anything above, like, we're not going to do like planes in 3-dimensional space or anything like that. So let's look at how we look at lines. So let's think of, I'm just going to make up a equation. Let's say y is 2x plus 1. Okay, we can make a table of x and y. Let's do -2, -1, 0, 1, 2, and this will get us started anyway. Whenever we plug in -2 into x, we get 2 times -2, which is going to be -4, plus 1 is -3. I'll leave you to fill in the rest of these, but or to fill in the details for the rest of them. But I'm just going to go ahead and write down what the equation is for each one of them. So this one's going to be -1. This is going to be 1. This is going to be 3, and this is going to be 5. Okay, so now we have these xy pairs. We can actually plot them. And I've alluded to this the entire semester. If you remember back, even in the very first video, I told you that these linear equations that we're solving, they correspond to trying to find intersections of lines in space. And so let's look at these lines. We don't need the, well, yeah, we do. Let's do this better. Let's plot it up here. So here's -2, here's -1, there's 0, 1, 2. And here we have 1, 2. See, we need to get up to 5, 3, 4, 5. And then we need 1, 2, 3. Okay. So this is 1, 2, 3, 4, 5. This is -1, -2, -3, -4. I'm going to use red for these coordinates. So whenever x is -2, so we're on this line here. Whenever x is -2, y is -3. So it's right there. Whenever x is -1, y is -1. So we're right there. Whenever x is 0, y is 1. And you're going to see very quickly that I did not do a good job at lining up this coordinate system. Whenever x is 1, y is 3. And whenever x is 2, y is 5. So if you kind of connect all the points in between, and again, I didn't do a perfect job with the axes here, you get a line. And so this equation is a linear equation because it corresponds to a line. Let's go back to our squared paper, and let's write the exact same, just, I think it was 2x plus 1. Okay, at 0, it was, I'm going to call this point 1. There's 2, there's 3, there's 4, there's 5. There's -1, -2, -3, -4, -5. And then we have 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. Okay, we plug in -2 here. If you remember, we got, we plug in -2, we get -3. I need to be doing this in red. -3, which is right here. whenever we plug in -1, we're going to get -1, and then we get this one, and this one, and this one. So I'm sure there's a way to draw a line. I honestly don't know how to do it, but we get a line connecting these guys. So everything we've done in algebra that we've done so far has a corresponding interpretation in geometry. And this was realized back a long time ago. This coordinate system is sometimes called the Cartesian coordinate system. And the way that Descartes, René Descartes, the French philosopher, mathematician, scientist, the way that he supposedly thought of this is he was lying in bed and saw flies on his ceiling, and he was trying to think, how could he communicate to someone where those flies are at? And so those flies to him were the points in space, and then he came up with this grid system. I'm sure that it was around before him, but he kind of gets the credit for it. Okay, there aren't there's nothing else left on the coordinate plane, but we do have graphing lines, which is the next lecture. And we'll talk about, that'll be the final lecture.